So, very reasonable lesson today about trapezoidal rule. Very reasonable, makes sense, you'll see it. Some of the applications are bizarre. And we'll get to a little bit maybe today, and then some others another time. Maybe on Monday. Just to give you a heads up now. So look at the sheet that you got in front of you. It says it.
I see it.
And you see, very similar to what we did before. If we wanted to integrate 1 over x dx, which we can't do as yet, right?
Yeah.
Why can't we do it as yet?
Because
Why can't you integrate 1 over x dx?
we don't have a,
It's actually negative 1, which would be x is 0.
Could be 0.
So
Finish the sentence.
So it's 0.
Undefined.
That's the problem.
But it's not.
So we would approximate it at this point in time. And we used, it looks like the same diagram we had for RAM and LRAM, yes?
Yes.
Mhm.
Difference is this. So for one of those rectangles, either you do the one on the right wall, way off, yeah? Or the left wall, way off.
Yeah.
But what if you made a trapezoid instead? 2 parallel sides, 2 non-parallel sides, Garish? It'd be so much better, wouldn't it?
Yeah.
That's going to be the trapezoidal rule. Okay. And the applications, again, there are many applications you'll see. Let's just keep reading there. Instead of a RAM, we use trapezoids. And a formula for, what was the formula? Just for area of a regular, how you doing trapezoid? Yeah.
so height over 2 times base 1 plus base 2.
Yes. Remember that?
Yes.
Let me just get this out because it's not working anyway. I can take attendance on this.
Oh, yeah.
Hello. So what you're looking at here, if you look it down on the 5th line or so, where it says therefore 3 dots, t, really it's area equals, but we're doing t for trapezoid. 1/2 the base. Now look at what I used for the base. What's the base? And that should seem reasonable. For the diagram you see from 1 to 3, what would be the value of delta x in that example? Four trapezoids, 1 to 3. Answer?
1/2.
Yes. Change in x2 minus x1 over n. Finish? Okay. So that's why it says half delta x or delta x, and then it's y1 plus what? Plus 2 y2s. Now why do I have 2 y2s? How come I wrote 2 y2s? Yes.
Because it's used on both sides. Does you have one trapezoid from one side, and then the next trapezoid has that same side?
Yes, exactly the right reason. So for this trapezoid, thank you, that's a great answer. So for this one here, it's the sum of the bases, base plus base. For the next guy, it's base plus base. This guy got used twice, yeah? So does this guy. All the middle ones get used twice. It's only the first one and the last one that only occur once. So that makes sense.
That makes sense.
Good. Okay. And then I just rewrote it differently. What did I do for the next step, the one that I actually boxed out? From the one prior to that to that. Jason?
You just back it out of 2.
Not exactly. You're in the neighborhood. On our own block.
You divided it out of 2?
Not exactly.
Distributed to 1/2.
Yes, that's what it is. So really it's multiplying by 1/2, okay. So, and that's the form that we generally use. Half of the first, all of the second, third, fourth, all the ones in the middle. If there were 50 in the middle, it would be a whole of each of those in the middle, and then half of the last one. So that was the whole development. That was the theory here for this one. And it's worked out there for just for them, where the delta x is 1/2, as Russ pointed out, and we get an approximation for it. Kavish?
Yeah.
So then I wrote, try FNN, try the function integrator on your calculator for this function. If you do a numerical calculation,
Are we assuming that they're so close together that it's a line?
no, not in this first example, we're not. It's just 4 of them, they're fat, they're 1/2 inch or whatever it is.
So then how does the trapezoid if it's a curve?
How do you get to F and N?
So, because we're using an actual trapezoid, 2 sides that are parallel, 2 straight sides that are not parallel, to approximate the area of the curve. I want you to see when you use FNN that the answer's gonna be pretty close. What was the answer?
1.098,
And what is 67/60ths?
1.11.
So, pretty close. It's only 4. We're not even stretching it out, making it 50 or 100 trapezoids, it's just 4 of them. It should be off by a lot, it's not off by very much. That was just an indication to see that the trapezoidal rule is a reasonable approximation, even with only a few calculations. So Rachel just went, that's what I'm hoping everybody was gonna do. Looks reasonable, okay, good, that was great, you're practicing. Okay, why do we use it? So one of the applications, I think I talked about, and I'm talking fast, I'm sorry. One of the applications that we talked about was this one here. We used an LRAM and an RRAM for it. Ship at sea, remember? You could look at the time, you can look at how fast the engines are turning, but you can't really look at how far you've gone, because the ocean just looks the same wherever you are, yeah?
Mhm.
But if you do, remember the rate times time equals distance? So if you want to find the distance, you just do rate times time. So what we did here in a left ram is we took that 15 minutes from 7:30 to 7:45, quarter of an hour. If we did a left ram, we made an assumption that we were going how fast for that quarter of an hour, Eric?
28.
Yes. And for the next quarter of an hour, from 7:45 to 8, we treated as if we were going
21.
for that whole 15 minutes, or quarter hour. Yeah?
Yeah.
And what would be the last 15 minutes from 9 to 9:15 for that quarter hour, Max?
21.
Yes. On the other hand, we're going to right ram and we use the ones on the right, yes? So for this one now, I'd like to see what happens if we try a trapezoidal approximation. What's the delta x? In this case, it's not x. Do you know what the letter is for this one? The delta x that we factor out. It's not x. Anyone know what it is? The letter?
Delta T for
Yes, yes. So the delta t is actually given in the question. So what's delta t?
25.
Yes. So, of course you could say a quarter of an hour, or certainly 0.25. So remember, just in our final form, it's only the delta x, in this case the delta t that was factored out. And then we put a parenthesis. And what should we write then for the next piece of information? Ruth,
14.
great. I'm going to write it as 1/2 of 28. But you got it right. The next item we'll write down is B.
13.
21.
Skipped a lot, I said the next to the last one. And then plus, and the last one would be. So remember, please, this is just something you want to get used to. It's new today. Half of the first, half of the set of the last, and full of all the ones in between. Make sense? So this is something you could actually do. I would just type it in my calculator one thing at a time, bang, 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 get an answer. And it would be a relatively good approximation for the distance covered. Another application. Any question on that?
When you mean the distance covered, are you talking about the area?
How far you went? From
Oh no, but I mean like
7:30 to 9:15.
when you just have like a regular curve, are you getting are you looking for like the length of it or just like the area underneath
That's
it?
a great question. We're gonna be seeing it applied for all kinds of things, for areas, for lengths, for all kinds of things. It can be used for volume. It's a method of approximation, and I have to ease you into how I use it in different scenarios. So no, it's not always one thing. In this case, it's just length times width. I'm sorry, time times rate. That's all it is. Thanks.
Isn't for what you were saying, how the area under the curve is equal to the distance traveled?
Well, we don't actually have a curve
Right.
in this case. In the first example that you saw, it was area under the curve. That's one of the applications as well. Yes?
And this is better than MRAM?
Great question. In some ones it'll be better, in some it won't be better. It's hard to know. Can't really generalize. I'm going to write an integral expression here, dx. Remember me asking you this before. We saw this one before as well. If this was going, you were going to make up this question for another colleague of yours, and you wanted it to be integrable, what would you do to make it integrable? Because it's not. It's not a happy integral. Rich?
Can you take the ln of it so that negative x squared is
No, you can't take the ln of something inside an integral expression. That's never possible.
Put an x next to it.
So even better than x would be,
Negative 2x.
that would be perfect. But x would certainly make it integrable. It would then be a happy integral where u would actually equal,
E to the negative.
no, u would actually
X
equal, or negative x squared. And then the u would be there. But it's not. And because it's not there, it's not integrable. Can't do it. What we're going to do is approximate this integral using a trapezoidal approximation. And for these questions, you'll see when you do some homework, it'll say use n equals 5, 10, 2, whatever it is. So for this one, n is 10. Meaning we're going to create 10 trapezoids. We need to find delta x. What's the calculation to find delta x?
D minus a over n.
Great. For this one, it is therefore,
It's 1/5.
to get that.
2 minus 0 over 10.
Thank you so much. And you're 100% right. So now we've calculated the delta x. Let's just factor into there. So t is equal to
1/5.
1/5 times parentheses. Lane.
Half.
So far so good.
E to the 0.
So that's exactly correct. That would be e to the first item along the way. Plus, not a half of, but a full
Either one.
e to the 1. What are you going to be plugging in for x? You started with 0. You know what your delta x is. So what's the next value?
1/5.
Okay.
Yes. So it's actually e to the 1/5 squared. That will be the next value you're plugging in for x.
2/5.
Yeah. So you're incrementing each time by 1/5 because that was your delta x. How many understand what we're doing? I went to slow speak. Plus the next guy is 3/5 and 4/5, yeah? Etc. Let's get the next to the last, yes? Angie?
Isn't this only one line? I don't get how.
We're actually gonna have 10 trapezoids. N is 10.
No, but why are you using those numbers?
Why am I using?
Those numbers.
Because delta x turned out to be 1/5. The graph looks like this, and we're starting at 0, we have a trapezoid starting at 1/5, and then starting at 0, going to 1/5, there's one of them, there's another one of them. That's at 2/5. Since the delta x is 1/5,